Hi there, it's me Sanjay. Welcome to Pantech Solutions, and I warmly welcome you all for the series Deep Learning Masterclass. So, in this session, we are going to learn to build your first neural network. I hope you guys are excited for this session. If you are excited, please put "I'm super excited" in your live chat. So, good evening, everyone. So, let us welcome each and every people. So, Arvind, hi, hello, and Arokya, Jaya, hi, ma'am, and Nitesh, hi, Alkama, hi, good evening, and Murugeshwari, ma'am, hi, ma'am, and Narashima, hi, and Divyanshu, hi, hello, Rahul, hi, good evening, Piyush, hi, Priya, hi, and Purnima, hi, hello, and Kanchan, hi, and Nikita, hi, hello, Umar, hello, good evening, Saravana Kumar, good evening, and Vijay, good evening, and Divya, hi, good evening, and Shubham, hi, good evening, and Sumida Tiwari, hi, good evening, and AP Songs, hi, good evening, thanks for mentioning my name, and Naved Khan, hi, good evening. Yeah, so a lot of people are posting, super excited. So thank you so much, guys. I hope you guys are ready for this session. So first of all, before going on to the session, same as like you guys all know, so attendance link will be available around 4:30 p.m. So once the session is completed, start filling up the attendance form. Until then, please don't rush up for the attendance form. So here, first of all, we are going to work on neural network. Okay, so first of all, let us discuss about the neural network, like convolutional neural network. So we have already seen some speciality about this convolution, right? So while talking about this convolutional neural network, it will have the ability to have automatic feature extraction, and then it can able to process the spatial features. So for example, as we have already discussed that, so let us have this image. So from this image, instead of taking the complete frame, it can able to see the arrangement of pixels, and it can able to see only the certain part of the image. So that kind of application can be done with the help of convolution neural network. And also it is going to use convolution type of layer. Instead of using a recurrent connection, it is going to use the convolution connection. And while talking about the activation function, it is going to have the convolution layer, and then convolution function, as well as the pooling function. So while talking about the convolution part, so it is nothing but it is going to take the input image, and it is going to take the certain part of an image, and then it is going to apply some filter for a certain image, and it is going to process both things. And if it is giving the output, then that is a process of convolution. Whereas if it is taking the same kind of matrix, like a small part of the matrix, and from the small part of the matrix, if it is taking the maximum value, that is known as a maximum pooling. And if it is taking the minimum value from the certain matrix, that is known as a minimum pooling. And if it is taking the average value, that is known as average pooling. Okay, so for example, let us take this image. This is 25. Let us take, imagine like 25 cross 20 25, which means 25 rows and 25 columns, which is present in this image. Okay, so you just imagine this is an image. Okay, so or else let us take any other picture. Okay, you just take this book. Okay, so this book, you just take, or you just imagine this book as an image. Okay, so in this image, so it is as same as like this convolution neural network. It is not going to process the complete image, right? Instead of that, what it is going to take us, it is going to take the certain part of image. Let us take one square matrix. Okay, so let us imagine this book or this image is going to be a 25 cross 25, which means 25 columns as well as 25 rows are here. So each and every pixel values. So out of that, if it is taking only 3 cross 3 matrix, so 3 cross 3 matrix in the sense like if it is going to like a 3 cross 3 matrix, so if it is taking 3 cross 3 matrix, so out of that 3 cross 3 matrix, if it is applying some filter on the 3 cross matrix, and if it is giving some input, that if it is giving some output, that is known as a convolution. Whereas same as like if it took 3 cross 3 matrix, on the 3 cross 3 matrix, it is going, if it is giving the maximum value, that is known as a maximum pooling. If it is giving the minimum value, that is known as a minimum pooling. And if it is taking the average value, that is average pooling. Okay, minimum, maximum, average. Okay, you just note it down. In the pooling, we have 3 types. One is minimum pooling, and then maximum pooling, and then average pooling. Okay, so out of that certain matrix, if it is giving the maximum, that is like a maximum pooling. And then if it is giving the minimum value, that is minimum pooling. And if it is giving the average value, that is known as average pooling. Okay, so let us imagine, or let us see the structure, guys. Okay, so this is all about convolution neural network architecture. Okay, if you are seeing this convolution neural network architecture, so here we have first of all, I think you guys all remember the 3 layers. You just tell me what is the 3 layers, guys. Okay, in your live chat, you just tell me what are the 3 main layers of the neural network design. Okay, just tell me your answers in your live chat. Okay, so here also we have the same structure, but it contains multiple hidden layers. Okay, so here let us imagine the input which is given as number 2. Okay, this is the project which is going to be useful for like handwritten recognition. So for the handwritten recognition, the input image which is we have given as number 2. Okay, so input number, that is number 2, that is 28 cross 28 cross 1. Okay, so 28 cross 28 cross 1 means it is in the dimension of 28 cross 28, that is 28 columns and then 28 rows, and 1 is channel. Okay, so for example, if there is a 3 instead of 1, so if it is there is a 3, that is a color image. Okay, so since it is a 1, it is going to be a binary image. Okay, binary or grayscale image. Okay, so yeah, we are getting response from Chiranjeevi and Divya and Rahul. Yeah, so input layer, hidden layer, and then output layer. So these are the 3 main layers. Thank you so much for your response, guys. Okay, so out of the structure, so this part is going to be the input layer. Okay, and this part is going to be the output layer. Sorry, it is going to be a hidden layer, and finally we have the output layer. Okay, so I'm again repeating again. So this project we are going to classify, just for an example, this architecture is about handwritten digit classification. So that's why here we have given input, that is handwritten image, that is number 2, and it is going to be passed on to the upcoming hidden layers, and finally we have the output layer. Okay, so here there is a number of number of neurons. It is going to be a 10 neurons. Why it is going to be a 10 neurons? Because each and every neuron, it is going to represent a single digit. So for example, first neuron is going to represent 0, and second neuron is going to represent 1, and then 2, and then 3, and then 4, up to etc. It is going to represent 9, because it is an output layer which contains multiple classes. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally up to it is going to have 10 neurons. Okay, so first of all, input layer, and then it is having the multiple hidden layers, which contains like first of all convolution layer, and then max pooling layer, again second convolution layer, second maximum pooling layer, and we have the fully connected layer, and finally we have the output layer. Okay, so these are the layer structure which we are here. So okay, so the input image which we are given is 28 cross 28 cross 1. So that is the input image which we are given. So it is going to be processed. So for example, as we have already discussed, it is not going to process the complete image frame. Instead, it is going to take the certain square. I think it is not visible clearly here, but you can see this grid. Okay, this is the square part. Square part is nothing but it is going to see the certain group of the pixels. Okay, it may be like 3 cross 3, it may be like 4 cross 4, it may be anything. Okay, that is known as a kernel. Okay, it is going to process the certain part of an image, and it is going to pass to the other kind of like upcoming hidden layers. Okay, so each and every hidden layer, it is going to process something. So convolution, what is the process or function of convolution? It is going to take the certain part, and it is going to apply the filter on that certain part, and it is going to process both and give us the output. That is a convolution. Whereas if you are talking about the maximum pooling, it is going to take the certain part. So from that certain part, if it is going to transfer the maximum value, that is known as a maximum pooling. If it is transfer the minimum value, that is known as a minimum pooling. If it is transfer the average value, that is the average pooling of the certain matrix. Okay, so that's what the function of these layers. Okay, so input layer, and then hidden layers. So hidden layer, what is the purpose of using hidden layers, guys? So hidden layers purpose is going to extract the features, right? And then fully connected layer, so which contains like normal artificial neural network, and finally we have the output layer. So output layer which contains like 0, 1, 2, 3, up to 10 neurons we have at the final part. Okay, so before that there is one method or one process which has been done here, that is known as a flattening. So I'll tell you what is meant by flattening. So before that, you just understand this flow. Okay, so if you are clear up to now, so you just put I'm clear in your live chat. Okay, so I'm repeating again. So this convolutional neural network architecture, it is going to see the some part of an image. Okay, that is a two digital image which is present there. So instead of looking the complete image, it is going to take the certain part of an image, and again, so first of all, let us take this is the same image. So on the same image, so first of all, it will take the square of this part, and then square will be appended like this, and then again square will be like this, and then again square will be like this. So likewise, it is going to see each part of the image likewise. Okay, so and after that, it is going to pass to the next layer, and the next layer, and the next layer, like this it is going to transfer on. Okay, finally we have the output layer. So on the output layer, how many neurons are there? So like in the output layer, we have totally 10 neurons. So why 10 neurons? Because each and every neuron which is representing a single digit. Okay, so the first neuron, so this neuron is representing digit 0, and this neuron is representing 1, this neuron is representing 2. Likewise, each and every neuron which is representing a single digit. Okay, so this is the convolution neural network architecture. So before that, there is a flattening also done here. So I'll explain what is the flattening mean. So before that, I hope you guys are clear up to now. So thank you so much that a lot of people are posting. I'm super clear. Okay, so let us go to the next step. So here we need to apply like Softmax. So let us take, we have already discussed a lot of activation functions, right? Like Softmax, Sigmoid, and like Relu. So there are a lot of activation function which we have discussed. So here, let us take the Softmax. So before taking a Softmax, this is the flattening, guys. This is an image and this is the flattening. Okay, so how it is got 784, guys? If you have any guesses, you can put your answers in the live chat, guys. How there is 784 pixels? Okay, so you just tell me how there is a 784 pixels. So I have the input image that is 28 cross 28 cross 1. So how we got this 784 pixel? I'm repeating again. So this is an image, okay, which contains 28 rows and then 20 columns, because since it is a low very small image, I can't able to draw 28 rows and then 28 columns. So for demo purpose, I've initiated only a few columns, 1 2 3, only 5 columns, and then 5 rows are here. Okay, so but you just map into 28. Okay, 28 cross 28, 28 cross 28, which means it contains 28 rows and then 28 columns. So what is the so flattening means it is going to take a certain part, it is going to be flattened. Okay, how there is 784? Okay, yeah, we are getting the response from first answer by Akhil Bolla, who told 28 cross 28, and Deepika and Greshma. Yeah, that's exactly right, guys. So and then Tarun, Nitin, and Kanchan and Komal. So yeah, so that's the answer, 28 cross 28. So I'm repeating again, you just look at me, guys. Okay, so let us take, this is an image, guys. Okay, so let us imagine you just drawn as a like number 2. Okay, so it is being drawn like a number 2. Okay, if this is an image, what does the flattening means? So we have already know that each and every, it is like this complete figure is nothing but a combination of rows and columns, right? So 28 columns. So 1 2 3 4, likewise we have 28 columns, and then 28 rows are here, 1 2 3 4, like we have 28 rows. Okay, so totally we have both 28 rows and then 28 columns on this image. So what does the flattening means? First of all, it will take the first column. Okay, out of the 28 columns, so 28 rows and 28 column, first of all it will take the first row. Okay, so first of all it'll take the first row and it will happen like this. Okay, how many pixels will be there? So that is like 28 pixels, and then it will take the second row and it will append with the first row. Okay, it will be like flattened into a single part. Okay, so I hope you are clear about the flattening, because flattening is also highly necessary to learn. Okay, so if you are clear about flattening process, you just tell me I'm clear about flattening in your live chat, I'm clear in your live chat. Okay, so what does mean is, so if there is, this is an image, if this is an image which contains 28 rows and then 28 columns, so 28 columns and then 28 rows, so this is the image. So what is the flattening process means? It is going to take the first row and it will put like this, and then it will take the second row and it will append with the first row, and it will take the third row and it will append like this. So likewise, each and every rows is going to be appended into a single row. Okay, so each and every row about like each and every row of this image, it is going to be taken and it is going to be flattened into a single row. Okay, that is what says 784 pixel means. Okay, the flattening which has been done in this architecture is this part. Okay, so out of this part of image, it is having that flattening process which has been done here. Okay, so thank you so much, guys. A lot of people are putting like I'm super clear. Okay, so this is all about here, guys. So this is the flattening process. So this is the input image, that is the number 2 digit which is given here. So flattening is done. So flattening is means, so we got 784 columns but only one row. Okay, so totally that image which we have is 28 cross 28 image, but by using the flattening method we got one row and 784 columns. Okay, so each and every cell is nothing but a pixel value. Okay, now on the output part we have how many neurons are here, guys? Just tell me your answers in the live chat. On the output layer, how many neurons needed to be here? Okay, so you just have your count and you just tell me how many number of neurons should be on the output layer. Okay, so here each and every pixel which contains like totally we have 784 pixels, right? So each and every pixel should be connected with each and every neuron of the output layer. So if you are seeing here, so here we have, this is the you just take this is the neurons. Okay, so each and every neurons or each and every pixel value, it is going to be connected with each and every neuron. Okay, yeah, first response or first answer by Kanchan, and then cryptography and Ajit Selvakumar, yeah, 10 neurons. So it's really great, guys, that I'm really happy that you all with me and you all following me and you all listening to me. That's really great. So why there is a 10 neurons? Because this is a digit classification, handwritten digit classification. So that's why we have 10 neurons, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally 10 neurons are here. So each and every pixel, so this is the first pixel, second pixel, up to etc. We have 784 pixels. So each and every pixel, it is going to be connected with each and every neuron. So for example, the first pixel value, it is going to connected to 0, and then it is connected to 1, and it is connected to 2, and then it is connected to 3, up to etc. It is connected to the 9th neuron also. Okay, so this is the normal connection, like without any difficult layers. Okay, so this is the normal function. Okay, let us talk about the softmax. So as we have already discussed, we have seen a lot of activation functions. So here let us discuss about the softmax. So softmax, this is the formula, exponential power ln divided by modulus of exponential power ln. So let us imagine, like, what does that L means. Okay, L is equal to x dot w plus b. Okay, so we have already discussed that what is meant by input, what is meant by neuron, what is meant by weights, and then what is meant by those, right? So here x is the input. Okay, so here we are going to find out L. Okay, so here we need to substitute in the softmax function. So for that, L is equal to x dot w plus b, which is nothing but product of input and then weights, and we are going to add biases. I hope you guys are with me. If you are with me, you just put I'm with you in your live chat. Okay, so here, so L is equal to x dot w plus b. What is meant by x? Input. So input, which is this one. Okay, this input. And then what is meant by w? W means weights. So weights are the numerical value which is going to be helpful for optimizing our model, as well as it is going to be helpful for modifying its weights based on analyzing the differentiation between the output as well as the predicted inputs. Okay, predicted output versus the input. Okay, so here L is equal to x dot w plus b. Okay, so L is equal to x means input, and then w means weights plus biases. Okay, so here why we are adding a biases is, for example, guys, product of 0. What is the value of product of 0? For example, if the input matrix is 0, okay, so if this is the value of 0, okay, if you are multiplying that 0 with any value, so the output will turn into 0. Okay, we should avoid that. So to avoid that kind of scenario, we are adding a biases. Okay, so thank you so much, guys, that a lot of people are posting that I am with you. Okay, so here we have this. Okay, so L is equal to x dot w plus b. So here x is going to be our input and w is going to be weights and b is equal to biases. So product of input and then weights plus biases. Okay, so product, I'm repeating again, product of input and then weights plus biases. Okay, so here x is going to be the input and w is going to be weights and b is going to be biases. Why we are adding a biases? Because if there is any input value which is turned into 0, then output will also turn into 0. So to avoid that, we are adding a biases. Okay, I hope you are clear up to now, and we can directly substitute by using the formula like softmax of x dot w plus b. Okay, so we can directly substitute and we can able to get directly output. Okay, I hope you are clear up to now. So if you are clear up to now, you just put I'm clear in your live chat. Okay, so that I'll proceed further. So up to now, what where we are, so this is the structure which we have seen, like basic structure of CNN, and here we have used a simple softmax classification without any complex hidden layers. So here this is the input. So instead of processing like complete matrix as an input, so we are going to flatten that image into a single row which contains 784 columns and a single row. Okay, so that complete each and every pixel should be going to be connected with each and every neuron which is present in the output layer. So totally we have 10 neurons, so it is going to be connected with 10 neurons. So while talking about the softmax function is we have this. So here we need to find out the L. So what is meant by L? L is equal to x dot w plus b. X is the input, w means weights, and b is the biases. So here product of it is nothing but it is a product of input and then weights, and additionally we are going to add a biases. Why we are adding a biases? Because if there is any input value 0, then definitely output is also going to turn into 0. So that's why to avoid it, we are going to add the biases. Okay, so let us see this, guys. This is for 100 image. Okay, so in this previous slide we have seen only for one image, right? So this is only one image, 28 cross 28, but whereas now this is for 100 images. Okay, you just forget about these parts, guys. Okay, you just forget about these part. You just see only this part. Okay, this is input image. So for 100 image, we have 100 flattening structure. Okay, so 100 cross 784. So what is mean by this 100 cross 784, which means 100 image. So the first image which has been flattened, that is 784 pixels. Second image, third image, up to etc. 100th image. Okay, totally this is the input. Okay, this is nothing but input for 100 image. So before we have seen only one image, same as like, so this is the flattening structure we have seen, right? Same as like we have did for 100 images. Okay, this is the first image, second image, third image, up to etc. We have 100th image. I hope you are clear about this input. What is this known here? So if you are clear, you just put I'm super clear in your live chat. Okay, so this is the 100 image. Okay, so first image which has been flattened as 784 pixels, and second image is also flattened, third image is also flattened. Likewise 100 images has been flattened, and we have the structure. Okay, we have this matrix. So what is the matrix dimension? So totally for 100 images we'll have 100 rows, but for matrix like column values we'll have 784. So totally we have 784 columns. So what is the dimension of this matrix? That is 100 cross 784. Okay, so 100 cross 784, this is the matrix which we have. So what is the formula, guys? L is equal to x dot w plus b, right? So x is also obtained now. So x for we know that for 100 images now we obtain the x, but now we need a w. So w is also a numerical value, so like weights. So here we are going to take like initials like w0, w1, w012, like up to etc 09. So there is 784 cross 10. As I've already told on the previous deep learning session, I told that you just imagine these lines as a weights, right? So I hope you all remember that point. If you all remember that, you just put I remember in your live chat. Because here this weights, you just imagine these lines are the weights. Okay, so each and every pixel, so there is a 784 pixels going to be connected with 10 neurons. Okay, so 784 pixels going to be connected to the 10 neurons. So that's why the weights lies from 0 to like 784 in the row wise, whereas in the column wise it is going to be connected with a 10. Okay, so w0, w0, 00, 01, 02 up to etc 09, and 783, 0, 783, 1, 783, 2, 783 up to etc 783, 9. Okay, so these are known as weights. So what is the matrix dimension of weights? That is 784 cross 10. Okay, these are the two matrix. So what is the formula? You just recap again. X dot w plus b. So x is also we have already initiated now. So by from the 100 images now we have, and w is also we know that we have for like 784 cross 10 matrix. And what is the thing which we need to do is we just want to do the dot product of input and then weights, right? So dot product of this input and then weights, we got the output matrix which is in the matrix of different matrix. Okay, why we have got 100 cross 10? Because I hope you all remember the formula which we have used to discuss during the school days, like 100 cross 784 multiples of 784 cross 10, which means 784 got cancelled, like because in my school days my faculties used to teach like that, because it will be very easy to understand and easy to remember, right? Because this is 700 cross 784 and this is a 784 cross 10. So 784 got cancelled. So totally you just remember that the output matrix of it is going to be in the dimension of 100 cross 10 matrix. So we have got the formula, we have got the output of x dot w now. Okay, now this part is completed and biases is needed. Okay, so biases is needed. Why the biases is needed is here the output neuron, so it is going to be 10 neurons, right? So that's why we are adding a biases. Okay, 10 biases, 10 neurons. Okay, so here 10 is nothing but a neuron, because if you are seeing the structure, each and every pixel, that is 784 pixel which has been connected to the 10 neurons, right? So 1 2 3, so even though it may be like 784 lines from that each and every neuron, so it is going to be like so first pixel value, it is going to be connected to 0 1 2 3 up to etc 10. So it is going to be connected to 10, so that's why 10 is here. Okay, so first one is x plus first of all the product of x and w plus b. So x is going to be input and w is going to be weights and b is going to biases. Okay, so I hope you are clear up to now, guys. If you are clear, you just put I'm super clear in your live chat. Okay, because so that if you are clear about this, you are strong enough in base. Okay, so that will proceed further. Okay, so if you are clear, you just put I'm super clear in your live chat, guys. Okay, this is normal thing, guys. It is normal thing which is for by using a softmax function which contains the equation that is x dot w plus b, product of input and then weights plus biases. So we are going to do the dot product of like input matrix, like this one is input for 100 images and this one is weights, and then we have done a dot product and we have get some matrix that is 100 cross 10, and then we have added a biases. Okay, so that's what up to here, guys. So I hope you all clear. So thank you so much, guys. A lot of people are posting super clear Sanjay, clear Sanjay. Thank you so much, guys, for mentioning my name. Okay, so that's all about, guys. Okay, so it is normal about function. Okay, now let us see with the TensorFlow, guys. Okay, so I hope you all remember the formula. So what is the formula? Softmax of x dot w plus b, right? So let us deploy it in a program. So y is equal to tf means TensorFlow. TensorFlow dot neural network dot softmax of tf dot matrix multiplication. Okay, mul, which means matrix multiplication of x comma w, which means x is already in the dimension of 100 cross 784, and w weights is already in the dimension called 784 cross 10. So it is going to be done the dot product, like matrix multiplication of two values, and we are going to add a biases. So biases, it is going to be 10. Okay, 0 1 2 3 4 5 6 7 8 9 10. Okay, once we got, if you got it will return you the computed probability, which means so each and every square boxes, like orange color square box which is present here, it is going to represent a single digit. Okay, for example, this first square box is represent a 0, and this one is a 1, and this one is 2. So out of this, it will try to identify which square box is getting more value. So out of this third neuron, okay, so third neuron which is getting 0.9. Okay, so what is mean by 0.9? Because it is giving the maximum value. So you just compare it with others, guys, like 0.1, 0.2, 0.9, 0.5. So out of this 0.9 is the maximum. So what it will do is, on the output layer, it will activate that neuron which is getting the maximum value. Like only one neuron will be activated and remaining neuron is going to be deactivated. Okay, so that is all about this like normal softmax function using a TensorFlow. I hope you guys all understood this. If you understood this, you just put I understood in your live chat. Okay, so this is all about basic workflow of this softmax function, guys. If you are understood this, you just put I understood in your live chat. Okay, I didn't understand the bias. Bias is very simple. Okay, so just to see this, so let us imagine the x value is 0. Okay, what is the dot product? What is the multiplication of 0? Definitely that will also turn into 0. So that's why we are adding the additional value. So even though your input is 0, output will not turn to 0 with the help of the biases. Okay, so that's why we are doing this biases, because if your input is 0, definitely output is also turned into 0. To avoid that, we are adding a biases. Okay, so thank you so much, Divya, Sandeep, Karthik, Anu, and Akhil. So thank you so much, guys. Lot of people are posting. I understood. Okay, so that's all about here, guys. So before that, we'll learn a basic syntax for using a Keras. As based on application-based learning, now we are learning a concept and we are also learning a syntax. And finally, we are going to create one project. Okay, I hope you all excited to create the project. If you are excited, you just post I'm super excited in your live chat. Okay, so here let us learn about the syntax, guys. So let us learn about the Keras syntax. Okay, so here we have model.add of dense of 12 comma input dimension is equal to 8, which means 12 is going to be the number of neurons, like first hidden layer, the yellow color circle which is present here, comma input dimension is equal to 8, like how many number of input dimension which is present here, 1 2 3 4 5 6 7 8. So this is the first input layer, and then hidden layer, there is a 12 neurons. So 1 2 3 4 5 6 7 8 9 10 11 12. So 12 neurons is in the first hidden layer, and we are also adding the second hidden layer, which is model.add of dense of 8 comma activation is equal to relu. So we are adding the second hidden layer, which contains the number of neurons, which is 8 neurons. So 1 2 3 4 5 6 7 8. Okay, 8 neurons are here. Okay, so this is normal designing a neural network. So how many neurons are required? So that is based on your tuning parameter. So if you are not getting proper accuracy, definitely you just want to change and you just want to observe. So those things. Okay, so here for an example, we have added like for input dimension, that is 8 neuron which is present at the input, and in the first hidden layer we have 12 neurons, which is a dense layer, and then we have added the next dense layer, which is about having 8 neurons. Okay, so we are adding the dense layers. Okay, so this is the layers which are present here, And if you want to compile your model, so definitely we need to compile our model to based on the certain matrices. So for example, from the syntax like model dot compile of loss is equal to binary cross entropy, optimizer is equal to Adam, matrices is equal to accuracy. Based on that accuracy parameter or accuracy matrices, it is going to optimize our model. Okay, so for that, here we are using a binary cross entropy. Binary means it may be like a different digit, like binary means 0 or 1, so something like that. Okay, so optimizer, so it is going to be a string identifier for an existing optimizer. And loss function, which loss function you are using, either you are using a categorical entropy, cross entropy, or binary cross entropy, and those things. And optimizer, so what optimizer which you are using, Adam optimizer. And list of matrices, so for any classification problem you will want to set this to the matrices, so like in which parameter you need to do like optimization. So for that we have given this accuracy. Okay, that's all about the basic syntax which we have discussed here. And there is another main thing which we need to know is a batch versus epoch. So what is mean by batch is like for example, if you have 100 images of apple, 100 images of banana, totally how many images which you have totally 200 images. So if the training process should see that complete 200 image, how much times it should look for the 200 image, so that is known as a epoch. Batch means how much group of data it is going to take as an batch, so that is a batch. Okay, as well as you can also save your model, and you can able to load the model by using model.to JSON syntax. So model.to JSON, so with open of model.json comma w, so w means write as JSON file. We are going to save the model in a file called model.json, and we are going to save the weights in the model.h5. Okay, as well as we are going to load the model, so we can able to load the model by using the same syntax, but you are going to replace that w with the help of with the r. Okay, so w means write, r means read. Okay, so we can able to load it, and we can use it in the different application, because if you are not saving your model and not loading it, especially on deep learning, if you are not saving the model and if you are not done that, so in each and every time there is a training needed to be done. Okay, for example, if there is a more huge amount of data set, definitely it may take more and more amount of time. So that's why, to avoid it, so you are going to save the model in our local directory itself, so whenever we need that, so we can able to access that trained model files. Okay, so weights files, so like if you want to save the weights file separately also you can do. Only thing is that going to be useful for like whenever you are handling like transfer learning, definitely we can use weights. Other than that, it is going to be useful for only this part. Okay, so I hope you are clear about this syntax, basic syntax. And if you are clear about this, you just post I'm super clear in your live chat. Don't concentrate on the attendance form, guys, because you can fill the attendance at any time, but if you miss the session or this knowledge, definitely it will be a great miss. Okay, so if you are clear about to now, if you are clear up to now, you just put I'm super clear in your live chat, guys. Because guys, up to now it is completely basics. Okay, so definitely it is highly necessary to learn a lot. Okay, so input image we have processed by using a Softmax function, that is x.w plus b. So we have done a product of input and then weights, and then we have added a biases, and we have learned some of the new Keras syntax, which is useful for adding a layer. So how to add a layer, and how to compile a model, and how to save a model, how to load a model. Okay, so these are the things. Thank you, Chiranjeevi. Thank you, Sanjay. Deepak, thank you. CSC Planet, thank you so much. Nagaraju, thank you. And Udit, thank you. And Yerni, thank you. Okay, so super clear. Thank you so much, guys. Okay, so super clear. Okay, guys. Okay, thank you so much for your response. So here I'm repeating this part again. So dense of 12 means, so how many number of neurons going to be on the certain dense layer, and then input dimension is equal to 8 means the input, how many number of neurons is going to be there is an input layer, and init is equal to uniform, and activation is equal to relu activation function. And model dot add of dense of 8 comma activation function is equal to relu. So it is going to take the next 8 neurons, and it is going to get the like input from the output of the hidden layer. Okay, it is going to process, and it is going to go further. Okay, so let us begin to build neural network, guys. I hope you guys are excited, and I hope you guys are ready to build it. If you are super ready, you just put I'm ready in your live chat. Okay, So let us build first neural network, guys. Okay, so before that, let us go here. Okay, so here we are going to work on a project which is PIMA Indians diabetes detection. Okay, so diabetes in the sense like which is going to be this PIMA Indians, which is for women's. Okay, which contains a lot of parameters like like amount of like times of pregnancy and sugar level. So likewise we have some of the features. Okay, so these are like features. So based on the features on the output class, we have the prediction. So 1 means diabetes is there, 0 means not a diabetes. 1 means again diabetes, 0 means not a diabetes. So positive or negative. Okay. So for this, with the help of this project, we are going to design a neural network. Okay. So I hope you all ready. Okay. So a lot of people are giving a response that I'm ready. Okay. So let us go for the first program, train.py. Okay, so here we have two Keras library, guys, and I think a lot of people haven't installed a Keras library. So please do one thing. I hope you guys all know how to install a library, right? If you know, you just put "I know" in your live chat, so that I'll send you the command to install like Keras library. Okay, if you know how to install it, you just put "I know" in your live chat. Okay, so definitely I'll give that version name or version number. Okay, so that you'll see run Python shell. First of all, you just want to install a TensorFlow, guys, and then only you just want to install like Keras. Okay, import TensorFlow. Okay, it is taking some time. Okay, cryptography, I know. Nitim, I know. Ajit, great. Devesh, no. Source code, okay, I don't know. Hardik, no. Okay, so I hope you guys, yeah, on the previous session itself we have discussed like how to install a library, right? I'm repeating again. So we have already configured a Python in the command window, right? You just want to type cmd and you just want to click run as administrator and click yes. Okay, so let us keep aside because we need to install specific based on specific version. Okay, still it is importing because it is little bit heavy, because that's why it's taking time. So shall we wait for, yeah, it is done. So import Keras. Okay, there is a second library. Okay, both libraries are installed now. So for me, okay, definitely I'll tell you how to do that. TensorFlow dot double underscore version Keras dot. Okay, so both version we have obtained now. Okay, what you need to do is you just take a pic of this version name, and in the command window with the administrator you just type pip. I think we have already know, we have already seen how to install a library, right? So pip space install space tensorflow dot, sorry, tensorflow double equals to 2.3.1. okay, you just like click that and you just install like this, guys. And if you have installed, you just put I installed in your live chat. Okay, so that's the procedure for installing a TensorFlow. You just want to specify the version as we have already did. Okay, and it's time to install Keras. Okay, so once the TensorFlow is installed, now type pip space install space Keras double equals to 2.4.3, because this is the Keras version which is 2.4.3 and TensorFlow version is 2.3.1, and then click enter. Okay, now that so it shows that it is requirement already satisfied because I have already installed both versions. Okay, so so that's it. Okay, so Kishen you have installed, it's really great. Okay, so Akebali you have installed, it's really great. Sanjay, okay, so installed. That is not TensorFlow underscore, guys. You just TensorFlow double equals to. Okay, so is pip space install space TensorFlow double equals to 2.3.1. Okay, I'll give the command in your live chat. Okay, so if you are really installed it, you just install like this: pip space install space tensorflow dot 2.3.1. Same as like I'll give it for Keras. in the live chat itself, you just install like this. Okay, so pip space install space tensorflow double equals to 2.3.1, and pip space install space keras double equals to 2.4.3. if you have installed and if you are ready, you just put I'm ready in your live chat, as well as I installed in your live chat. Okay, so that I'll proceed further to work on a program. Okay, so this is going to be a simple neural network design, guys. So first of all, here there is a comment. First column, which is representing number of times pregnant, and second column, which is representing plasma glucose concentration at 2 hours in a oral glucose tolerance, and diastolic blood pressure, that is the third column. Okay, so likewise, so based on this data set, so this is one. Okay, so and tricep skin folder thickness, that is the fourth column, and 2 hour serum insulin, and this is the fifth column. So likewise we have, and finally like eighth column, which is representing age, and ninth column, which is representing a class variables, 0 or 1. 0 means negative, 1 means positive. Okay, so yeah, a lot of people are already ready. It's really great, guys. Thank you so much. Okay, so I hope you understand this data set. So here we have features. So 1 2 3 4 5 6 7 8 columns are there. So these are known as features. So based on the feature, we are going to predict the person who is having diabetes or not a diabetes. 0 means not a diabetes, and 1 means a diabetes. I hope you are clear about this data set. If you are clear, you just put I'm super clear in your live chat. Okay, so now let us start writing a program, guys. So first of all, let us import load text library from the NumPy library, so which is going to be helpful for handle that CSV file. Okay, handle or load the data set. Okay, so first of all, we have imported from NumPy import load test. So these are like comments, guys, so don't include that. It is completely optional. Okay, you can use the as like comments, or you can use this triple quotes, like even if you are using like triple quotes like this, and then if you are closing it with this is nothing but a comment. Okay, it is just an optional, don't include that. Okay, so now let us go for the first library from NumPy import load text. So that is like handle or load test. And then second library, which is like keras.models import sequential, which means like empty work area, empty working area where need to where we are going to add the layers. Okay, so like empty area where we are going to add layers. Okay, now what is the kind of layer which we are going to use? So here I'm going to use the dense layer. Okay, so that's why we have imported a dense layer. So for example, if you want to add or if you want to import a like convolution layer, here we need to specify like convolutional 2D. So instead of dense, here we need to specify convolution 2D likewise. And keras.models, like model dot from JSON, it is not going to be used here. Okay, so I'm going to remove this line because it is going to be useful for testing part. Okay, so I think, okay, so that's all about these three libraries. So I hope you are clear about this library. First library, which is NumPy, going to be handled for like loading a data set, and keras.models import sequential, which is going to be helpful for creating an empty part where we are going to add a layers, and keras.layers import dense, which is going to add like dense layer. So whenever you need a dense layer, we can able to easily import it from it. And it's time to load the data set, guys. So into a single variable, dataset is equal to load text of pima indian diabetes.csv delimiter is equal to comma, because it is a CSV file, that is a comma delimiter CSV file. So we are going to segregate, we are going to load that complete data set. So what is the complete data set? So these are the complete data set. So this complete data set is going to be loaded into a single variable called data set. So once it is done, now it's time to segregate which one is input and which one is output. Okay, so you just tell me from this picture, you just tell me, guys, what are the inputs and what are the outputs? Okay, so at the meanwhile, I'll take some water, guys, sorry for that. Okay, so you just tell me what are all the input from this Excel sheet and what are the output from this Excel sheet. Okay, just tell me your answers in the live chat, guys. Okay, guys, I'm back. So from this data set, you just tell me what are all the inputs and what are the outputs, guys. Okay, so here we have this data set, so which contains lot of parameters, and this is like we have the classes. Okay, so yeah, we are getting the response. Yeah, the exact answer which I expected, which was answered by Chiranjeevi. The answer which is very simple. So out of this complete columns which we have, except this final column, these are all going to be my input, because if you want to detect the diabetes, we need these kind of parameter. So these each and every column. So 1, 2, 3, 4, 5, 6, 7, 8. So these 8 columns is going to be our input, and this is going to be the column of output. Okay, so thank you so much, and it's really great, Chiranjeevi, for answering me my question. And we are also getting a response by Shavi. A, B, C, D, F, G, H are inputs. Yeah, exactly. Okay, A, B, C, D, E, F, G, H. So up to this H column, so these are all going to be my input, and this columns is going to be output. So based on these columns, so you can call in different ways. Like these are like independent variables, and these are like dependent variables. Okay, these are all dependent variables, and these are all like X, and these are all like Y, and these are like features, and this is going to be our prediction result. Okay, so you can call it in different names. Okay, 0 means not a diabetes, 1 means a diabetes. Okay, so now it's time to segregate our data set into X and then Y. So what does mean by X? So X is going to be my input. So from that, so 0 to 0, 1, 2, 3, 4, 5, 6, 7. So it won't include the last column, because we have specified both, so starting point and then end point. So 0 colon 8. So out of that complete data which represent that colon, so it is the start column and then end column. So it won't include the range. I hope you all remember the range function. Same as like it won't include the last column, so it is going to take up to here. Okay, up to H. A to H column, it is going to be in the X variable, and without specifying the start value, if you have specified the certain column ID, that is 8th column, which is going to be output. Okay, so which is going to be Y. So I hope you all clear up to now. So if you are super clear with this, if you just put I'm super clear in your live chat, guys. Okay, so this is going to be my input. So what is the input? So up to A to H, this is going to be our input, and final column, it is going to be output. Okay, so that is what we got from X and then Y. So input and then output, and then what we are going to do is we are going to start building or start adding our like neural network. So first of all, we have initiated with model is equal to sequential, which means like empty area. On that empty area, we are going to add the layer. So model dot add of dense of 12 comma input dimension is equal to 8. So I hope you all remember what it means, right? So I'll show that picture here. Okay, so this is the picture which we have given us, like this layer. Okay, so 12 comma input dimension is equal to 8, and it is the activation function, which is a ReLU. Okay, so and then second hidden layer, which contains 8 neurons, and this is the second hidden layer. And third layer, this is the output layer, guys. Okay, dense of 1 comma activation is equal to sigmoid. So why we are using a sigmoid is it is it is like a kind of like binary classification. Why it is a binary classification, guys? Because the output is zeros or 1. Okay, so why it is zeros or 1? Diabetes, not a diabetes, positive or negative, true or false. It is either condition, either 0 or 1. So that is why we have used the sigmoid activation function. So 1 means it is a binary, like binary classification, either positive or negative, either diabetes or not diabetes. And model dot compile of loss is equal to binary cross entropy. So same as like a model dot compilation, which has been imported here, and model dot fit. So this is the method for training, started training, guys. Okay, so model dot fit of X comma Y, so input comma output comma epoch is equal to 5. So how many iteration should be happen throughout the data set? So for example, from this data set, how many rows are there? Totally 768 rows. So how much time it should go towards the 768 rows means? So that is 5 times. So that is the epochs, and batch size is equal to 10. So how much group of data it is going to be processed at a time? So that is the batch size. So for example, if you are using a high or huge batch size, you will get an like error that is you will get an error that like batch size means you will get the error like memory error. So if you are getting the memory error, that means like you are out of the memory. So that's why you should use the minimum batch size. Okay, so and after that, what we are going to do is and then we are going to add like we are going to evaluate our model. So to evaluate our model, model dot evaluate of X comma Y. So what is X? So that is input, and what is y, which is going to be output. So model dot evaluate of input and then output, it is going to give us the accuracy. So accuracy multiples of 100, it is going to give us in the percentage of, okay, percentage unit. And finally, we are going to save the model in our local directory in the two format. One is model.json and then model.h5. Okay, totally we got two model file which is going to be saved in our local directory. Okay, so model.json going to hold on our models information, and .h5 which is going to hold on our weight data. Okay, so that's all about this session. I think it is very it is super easy, right? So let us run the program. If you really want to run the program from the command window, because if you are running a training process, if you are running from the ideally, definitely it will be very hard to observe. Okay, that's why I'm going to run it from the command window. So cmd and then enter. So it will open the command window on that specific directory, and here I'm going to type python space train.py. okay, and then enter. So if you are running that, it will take some time to load each and every library, and it is going to start a training process. Okay, so 1 2 3, so it done a 5 epochs. Totally we got 58 accuracy, 58% accuracy. It is not good because it is not tuned properly. Like there are a lot we need to add more number of epochs, so that it will take more time. So that's why I've given a very less epoch. You just increase the higher epoch. Should be happening, like, to handle it in a better way. Okay, you just please aware of underfitting and then overfitting. Okay, just to see once about these kind of concepts. Okay, so these all about here, guys. So training is completed, and the model file will be saved in our local directory, that is model.json and model.h5. okay, same as like if you want to test the program, so you can also test the program by using the same kind of format. So I'm going to take like normal kind of library, so same library like model numpy, and model from json library going to be helpful for load the data set from the local directory. And we have specified the data set, same data set, and then we have segregated data set into x and then y. And we have loaded model.json read, and we have loaded that both model file and then json file. And prediction is equal to model.predict underscore classes of x. So here what is going to be x is, so here we are going to pass that input data set. So complete data set. Out of the data set, I'm going to take only 5 data set, like 5th row to 10th row. So it is going to process only 5th row to 10th row, and it is going to give us the result. So let us check the output. So python space test.py. okay, so it will give you the results that, so it given a results. So the 5th column, which is original class, is also 0. So out of 5 marks, let us see how many marks our model is being scored. Okay, so out of the 0, so our model is also like scored as 0. Okay, 0 0. And then original class is 1, but our model is predicted as 0. So original class is she is having diabetes, but our model is predicted not diabetes. Okay, so say first is wrong. Okay, so that is second is wrong, and then 0 as 0, so we have scored as second mark, and 1 as 1, we have scored 3 marks. So 1 as 0, so out of 5 marks our model got 3 marks. Okay, so totally 3 only is right. Okay, so if you are increasing, or if you are tuning some of the hyperparameter by increasing the data set, by increasing the number of hidden layers, by increasing like neurons, and by increasing like other features, or you can increase like epochs. So likewise, if you are tuning that, you will get a better performance. Okay, so that's all about this program, guys. It's very simple, I think so. Okay, so is it simple, guys? You just tell me your thing. So is it simple? Is it simple, or is it looks easy? Because within 10 lines of program, we have built a basic neural network for diabetes detection. So if you are feeling that it is very simple, you just put it is very simple in your live chat. Okay, so you just tell me your answer, or tell me, or just share your response in the live chat, guys. Okay, it is very simplest program. We have designed a neural network, simple design neural network to predict the diabetes, diabetes or not a diabetes. Okay, Ashwita, thank you so much for posting that, super clear. Okay, so that's all about here, guys. I hope you guys all enjoyed the today's session. Okay, so before that, definitely it is about internship introduction. So there is also artificial intelligence internship. That is a 30 days internship, guys. If you really registered for the internship, you will get 30 days of video lecture. You'll get internship printed certificate. You can able to download the source code, a PowerPoint presentation, mind maps, and data sets, and pre-trained model files. Each and everything you can able to download it, as well as you'll get Telegram VIP group. So that is like whenever you have any questions, you can raise your questions in the Telegram VIP groups. Our community is there to clear your doubts. And then this artificial intelligence masterclass, which is about be only provided for 590 rupees, as well as the machine learning masterclass, which has been provided for the price of 499. Okay, if you really want to register for it, please click the link and just please register for this internship, guys. Okay, anyhow, I'll send the link now. Okay, so artificial intelligence. Okay, so I'll give that link. Okay, AI masterclass. Okay, so I'll give the artificial intelligence internship link, guys, to register. Okay, so Chiranjeevi, that you are posted, you already registered. It's really great. It's really good to have that, guys. Okay, so on Saturdays you may have live with me only for the paid participants. I hope you guys are excited to have that. Okay, so and finally we are in the Q&A session, guys. If you have any questions, you can ask your questions. Why data pre-processing steps is not done? Okay, actually that is based on your like scaling algorithms. For an example, if you are using a k nearest neighbor algorithm, that algorithm is based on the distance between the each and every feature. So that's why it is completely, or it is highly necessary to do the scaling process. Okay, that is scaling is based on the some different parameters. So it is based on the your data, like you are, first of all, it is based on your algorithm, and second thing, it is based on your data. So based on that only we need to design whether we need to do a scaling or not. Guys, some people are asking in Hindi. I really am telling that I don't know Hindi. Okay, so you can raise your questions in English, guys. Sir, I have registered for machine learning masterclass. Okay, if you are registered for the machine learning masterclass, it has been already started. Okay, so don't worry, it has been updated. Okay, so it has been updated each and every day. How did you extract features? So extracting features in the sense, so as I'm repeating again, deep learning, while talking about the deep learning, it is not about you to mention the features. It is going to automatically extract the feature, and it is going to automatically make a decision. Okay. Telegram VIP link. Actually, Telegram VIP link is for the internship participants. Okay, if you register for the internship, you will get the login access portal about like learn.pantechsolutions.net. Okay, you will get login access for this portal. So once you have got login access for this portal, you just go to the course. Okay, AI masterclass using Python 30 days internship program. So if you are scroll down to the last, there is a Telegram link. Okay, so you just click that link and you can join with us on this VIP community. Okay. Uh, okay, so he's replying in English. EEG signal processing BZI model webinar. Of course, but due to this lockdown, you know, guys, we have missed that device kit. Okay, definitely we are already planning it for. Definitely will provide the brain computer interface technology. I hope you all excited for this BZI webinar. Also, it will be. It is going to be a very impressive and attractive and innovative technology. It's really great. Definitely, I'll give a webinar for that. Okay. Not much easier without I didn't get what it means. Okay, you can raise your what's really you want to say, just tell me, guys. Okay, guys, I think we are in the end of the session. Okay, so thank you so much once again. So guys, if you guys people haven't followed me on sorry, LinkedIn, you can follow through my LinkedIn. The LinkedIn link is also given in the description below. Please follow on this our Instagram profile. The link is also given in the description below, and please follow on the Facebook AI community link, that is also given in the description below. And if you have any course related doubts, you can raise your questions in the 9840974408 to this number. You just ping it to the WhatsApp number. And if you want to know about any project or product, please visit pantechsolutions.net. And it's really great that you are connecting with me. Please have a hands-on practice. Okay, you just go through and you just have some practice by yourself. So that is all about complete hands-on. Okay, so only 2 days are remaining, right? So it's really great that people, you guys all connected up to the 3 days. It's really great, because if it is a paid session, that's definitely you will connect, because you should not waste money. But even though it is a free session, you have attended so far up to like 3 days of session. So I really feel happy about each and every people who are connecting with me on this third day. So only 2 days are remaining. So on the 2 days, it is also going to be a hands-on. Okay, don't miss out that session, and each and every day that link will be sent via email. Okay, don't miss out this session, guys. So thank you so much. Thank you once again. It's me, Sanjay. Until then, bye. We'll see you on the tomorrow session.